Okay, RDD we covered like a resilient distributed dataset. Why we call it resilient distributed dataset? So there are type of operation on RDD. Okay, one is action and another is transformation. Transformation is like uh, you will take one RDD, do some transformation on it, and it will return you another RDD. Then again you do some transformation. Then again it will return you one another RDD. So one transformations on one RDD will return you another RDD. Once you perform the action, you will get the result. Okay, and result will be sent to driver. We have worker and drivers, right? So on the worker, these transformations will happen, and once write the action, it will be calculate the final result and return it to driver. Now we'll see like what are the transformations and action. Not all, but few we'll see, and again we'll come back to it after reading the Scala.
Okay.
After learning the Scala, we'll come back again, or just to look at again what are the actions and the transformations. So as I told you, in the transformation, you apply some function to RDD to create a new RDD. So one transformations can be like filter. Transformation means transforming the data. So let's suppose I have a list, okay, and which list has number A, B, C, D, okay, and I want to transform it a capital to a small. So in this way, I will, if I just do lower, okay, it will return me. Let's suppose list is some RDD. The RDD name is list, and I wrote RDD to lower. So it will return me output something like it A, B, C, D. Okay, so the proper and this will be list dot map x equal to x dot lower, something like this. It will be, but I'm just on the high level. It will, if I want the lower number, I will just write list dot lower. So transformation is if you want to transform intermediate data to some other data, then we use this RDD. So what are the ways to create the one of the most common is like filter. Whenever you are filtering any data, which will return a new when you filter any data, let's suppose if I employee ID employee table and it has ID and age. So 1, 3, 15, 30, something like that. So if I filter, let's suppose I want to filter the age where age is greater than 20. Okay. So initially it will be this RDD. Once it reads the data, it will have this RDD. But once I apply the filter of age greater than 20, then I will return new RDD out of it where my result will be RDD age. ID will have just the 3 and it has 30. So this is another RDD. Okay, so once we perform any transformation like filter, it will return you one RDD. This is one RDD, and after transforming, we'll get another RDD, right? Got
Yes.
it? And
Yes.
there are way. So in this case, as you are seeing here, we are reading the data. Okay, this is the path where the your file is, and then
Mm.
you are this is in the Python program. So
Yeah.
that's okay. So you are filtering it, and you are finding Friday in line. So it return you some filtered output out of it. So the action is like it once you perform. Is there any echo from your side or the voice? Okay.
Yeah, actually, when you're talking, I'm getting it just now.
Alright, let me just join again then.
Yeah.
Okay, so I was talking about actions. So action is like once you perform this, it will get the result and send it to the driver. So the one action is like first, like we have filter as a transformation. One action is first. First will give you the first line from the result. You have this table, employee table, right? If you write, let's suppose you do after this, let's suppose our upper.txt has this data. Okay. So once you read it, let's suppose I filtered. Let's just add one more record here, 4, and let's just give it 22. And I'm filtering the age greater than 20, so I will get 2 record, right? I will get, okay, I will get record like ID, age. ID will be 330 or 22. Okay, after filter, after age filter, age greater than 20, I will get this record, right? So let's suppose filter I applied where age is greater than 20, this is transformation. And let's suppose on this RDD I applied, let's just give this RDD as name RDD2, RDD2 dot first. Okay, if I write this, then it will return me only the first record. Okay, it will print this, or it will send this to the driver, and driver will get on, and driver will return this record to us. Now, the general workflow of the RDD will be like you will initiate RDD while reading this. Okay, this is like kind of initiating the RDD. Then you do some transformations. Like let's suppose you did some age filter, like filter on top of it, and then you got the action. So these are the three generally, or only these three general operation. What you do, you create RDD or from the external data. External data means, see, this is the file which is on your local. So maybe your file is on HDFS or your file is on S3. You will read it. Once you read it, it will create one data, one RDD. So transformations are the operation on RDD that return a new RDD, such as map and filter. Map is also one transformation. For now, you just understand these two are like transformations, and collect, count, first. These are actions. And what action will do? Action or operation that return a result to the driver program or write to test storage. Let's suppose instead of, see, when I did the count, it's sent to the driver. I may do like, let's suppose my final RDD is RDD3. I can save it, save to save as text, and then I will give the location where I want to save. We'll see all those things, how to save and all those things we'll see in the RDD. So can you tell me what is the difference between transformation and action? We just saw, right? What difference you see in that?
Transformation data is different in after transformation.
And in action?
Action is like filtration of data.
So filtering of data and all are transformations, right? Action is count,
Okay.
and then first, then if you are saving somewhere, so action will give you the result. So let's suppose I want to count the line. Let's suppose I read the data and I want to count the line. I will use the count. It will return me the line, how many lines are there. Okay, so how transformations and because the way how what are the different, like how RDD compute. See, one more thing. Let's suppose that I have this thing. Let's suppose in RDD1 I read one file sc dot, what is sc Spark context. We'll see about, we'll read about this
Okay.
sc dot text file, and this is the way we read. Let's suppose we gave the file a.csv where we has employee table. After that, we implemented a filter on it. Let's suppose after that I implemented group by on this. So let's suppose I want to get the sum of age. So I filter it age greater than 20, and after that I am summing the age. Okay, let's suppose I am getting the sum of age. So after filter my output, what was the output? I have like ID and age. Then I have ID is 1. Let's suppose age is 20, 22, second age is 30. So this is the final output which I got after filtering. So now I am summing the age. So after this, what I will get? I will get ID, age. So I'm just getting the age. So I don't need ID because I'm grouping it by, I'm just getting the sum, no group by. So age, it will return 52. So this is the final output which I will get. Let's suppose after the sum, I am saving it somewhere. Or let's suppose I'm saving this output as location. One location which is b.csv. Okay, let's suppose in this CSV I'm storing this data. So what is the chain? It will be chain. It will be like I have RDD one. I'm doing some transformation. I'm getting RDD two. I'm doing some transformation. I am getting RDD three, and on the RDD three, I am doing some action which will return me the result. Right? This will be the chain.
Okay. Okay.
Correct? You are doing
Yes.
this RDD, then filter, then sum, then so this is the chain where on the RDD one I'm doing transformation, then on the RDD two I'm doing transformation, on RDD three I'm doing the action.
Okay.
See, this is one term, lazy evaluation. So we call it as lazy because until unless you write this action, okay, like save, like count, like find, RDD won't start doing these things. Let's suppose that if I write something like this, a.csv here, okay, and so if you write action, then only it will start calculating these things. And before that, you think that it will just store in its memory that what I have to do. Let's suppose it will store into the memory that on the RDD one I have to do the filter, and then RDD two I have to do the sum. Okay, these things it will store into its memory steps. Okay, let's suppose these steps it's stored into its memory, and then once you give this action like count first or save, then it will start doing this computation.
Okay.
Okay, see here, nothing would happen. Nothing would happen when a Spark see the text file. So you are reading the text file. Okay, nothing will happen. Once you filter it, nothing will happen. Okay, nothing will happen here. Once you write this first, okay, then action is called on the lineage with RDD. Spark only start loading the uppercase to text when first action is called. So here I am just converting it to upper. Okay. Uh, so we have upper text case file. File name is uppercase.txt. Okay, and then we are filtering the line which has Friday. So if you write these two, nothing, Spark will do nothing. But once you write the first means this action, then it will start loading the this file and then filtering these things, and then it will do after that only whatever you have as transformation you have written. So as a Spark only do things, calculate things once you write the action. That's why we call it lazy evaluation. Means lazily I'm keeping this into my memory somewhere kind of steps. And once you write the action, then I will start evaluating these things.
Okay.
Okay.
Action is like filtration only, right? No, no, no.
A filter is transformation.
Okay.
Action is first. First will give you the first record.
Okay.
Okay. Collect will, there is one more collect. Collect will give you all the record. It will collect the result to you. It will collect the result of all the transformations. Let's suppose here you filter, right? Filter is transformation. So once you filter, you get some record, you collect with. send you those collect into, so let's suppose it will collect it, all the record, and it will send back to the driver. So collect first, save, if you are trying to save any data, those are actions.
Okay.
So that's what I mentioned. Rather than thinking RDD as a containing a specific data, it might be better to think each RDD as consisting of instruction on how to compute the data that we are building through the transformations. So transformations won't do anything until unless you perform the action. So transformation return RDD, right? So if I'm doing any filter and all, it will transformation will return another RDD, whereas action will return some type of data, some other data type. Some other data type means uh, here let's see this. Here I'm filtering, so this is transformation, right? Here also I'm filtering, this is transformation. But once I did the action like collect or first, it will return me the proper data, okay, not the RDD. It will give me some result like what RDD dot collect, maybe it will give me some file where we have data, but here it is return me one RDD. After filtering also it is returning me one RDD. This we call as one RDD because I'm doing the filter on it, and it will, I have, let's suppose I have a line. In the line, we have written sc.text file, and there I have given the path. So this is one RDD. And when I'm doing the filter on this, this is also returning me one RDD. In the transformation, we are returning RDD. In action, we are returning the data type. Other data type means some response. How to create the RDD? You saw that one way of creating RDD is from RDD. If you do any transformation on one RDD, it will return you another RDD. That is one
Mm-hmm.
way. Other way is reading the external data source. Right here, you read this. You read this data file. This is external data source, right? Maybe it in on your local computer or on HDFS somewhere. So in this way also you can create one RDD. Two most common transformation are filter and map. You just remember these things because we are going to use this further also. Okay, just remember that we have filter and map, which is the transformation. And filter, you understood that it will filter the data. Map will write, uh, let's suppose I have list, okay, or let's just take the same example. Uh, emp.csv, which has files, right? Uh, ID, age, ID 1, 2, age 20, 25. Let's just give one more record, 30. Now, what map will do, let's suppose that you want to subtract the age from each ID. Like let's suppose you want to subtract two year from all the ages. Okay, so in this way you will use the map. What map will do? Map will iterate through all the element of your file. See, it take a function and pass each element into the input RDD through the function. Okay, so once you read it, we'll see that how map and all are doing in the Scala. But for you understand, because we are going to use this map in other explanation also, so try to understand this. So
Okay.
what map will do? Map will take the element and it will try to do some action on each element. Let's suppose I want to subtract 2 from each age, right? So it will go to the age and will take each element. Like first it will take 20, then it will do subtract, then 25, then 30. Something like that it will do. So here in the map, from one element you are getting just one element, right? With this, what I mean that after it will take this element 20 and will subtract 20 minus 2. It will return you 18, right? Here it will
Yes.
return you 23. Here it will return you 28. So from one element, it will return you only one element.
Okay.
But in flat map, there is one other which will return, it will take one element and it may return more than one element. Or it can return zero element also. It may produce zero. In the similar way, it will go through all element and it will do some action on it, and it may result zero or one or many output of each element. How we are doing the map, similarly, instead of map, we will do the flat map. So it may return zero, one, or many output for each element. See in the map, we have these three elements and we are reading only three elements. But in the flat map, once we do, we may get more than one element. Okay. Distinct is also a transformation. Distinct as name is telling it will return you the distinct row. Action we understood that it will return the final value to the driver program or persist data to the external storage system means you can save it, you can store it to the other storage system. Action will force the evaluation of transformation, right? As I told you, until unless you overwrite any action, it won't do anything. So you can tell that action will force the evaluation of transformation required by the RDD. Collect is kind of action. Okay, collect operation, retrieve the entire RDD and return it to driver in the form of regular collection or value.
Correct.
Count.
Correct is like filter only.
No, collect is not filter. Filter will filter, as I told you, right?
Output.
Filter will filter the values of RDD, but collect will,
No,
let's suppose
not
after,
action. Collect is like action, right?
yes, collecting action. Count by value, these are also actions. Save as text file, these also action. Let's suppose that you created some RDD and you want to save it somewhere. So you can give it like save as text file, you give the path, it will save you. This is also a kind of action. Reduce is also action. We're not looking at these things. Now let's just look at persistence. Okay, what is persistence? Why we are doing this?
Sure.
Uh, Let me give you one example. Let's suppose I am giving you a table A. Let just we are representing table with alphabet, right? A one table, B one table, C one table, D one table. Okay, I want to join this. Okay, and then whatever the result I got, let's suppose I got result as AB.
You're sharing something.
Oh, shit, right?
Yeah, yeah.
So uh, let's just see what persistence is. Let's suppose that we have five table A, B, C, D. Let's suppose we have four table, okay, and we are and we have series of transformations. Like we are doing multiple transformations on it. Okay, let's suppose we are doing 10, 20 transformations. Now, I joined A and B and I got result as AB, and then I joined C and D and I got result in CD. And during these 20 transformations, I am going to use this A and B and C and D at multiple places. Okay, so you understood what I mean by 20 transformations, right?
Yes.
Okay, so let's suppose I have series of transformations like 20 transformations, and at the some place, let's suppose at the 30th third transformation, then after the fourth transformation, then 10th transformation, and after 12th transformation and 15th transformation, I'm going to use AB. So what I will do, I have two options. Let's suppose during the third and fourth, either I will again calculate it, I will join and calculate it, or maybe what I can do, I can store it somewhere. Let's suppose I store it into my executor. Okay. So what I have to do at the when I'm doing the fourth or 10th transformation, I don't have to recalculate it. I will directly read from the memory and I can use it, right?
Yes.
You are getting me?
Yeah. Yes.
So that thing storing into the memory we call as the persistence. Okay, so if I let's suppose maybe in the production, what you will find that okay, these are the something I have done. Let's suppose I joined something and I filtered something. Let's suppose I have very big, huge data set. Let's suppose I have 10 GB of data set, and I have one like 15 GB of data set. Let's suppose this is A and B, and I joined it and I got around 1 GB of data set out of it. Okay, let's suppose I filtered and joined, then I got this. So and this took around 2 minutes to calculate. Okay, let's suppose it took around 2 minutes to calculate this joining. After joining, I got 1 GB of data, and this took around 2 minutes. So when let's suppose I want this data for my third transformation and fourth transformation. So I have one option like I can recalculate. So if I recalculate, I have to it will take again 2 minutes. So instead, what I will do, I will store this 1 GB data to some of the executors, and when I need a third and fourth or tenth transformation, I will directly read it from there. So in this way, I saved my time, right?
Yeah. It means like every transformation, it stores the data
No,
and
it until unless you ask, it won't store.
okay.
Let's suppose that I know that I am doing some transformation and I know that this output I am needing in future.
Okay.
Okay, let's suppose I have series of 100 of transformation I am doing. Okay, and I join something, then I do multiple transformation. After that, I know that I may need this data further in my transformation somewhere. Okay, so which I understood, it automatically Spark won't store the data in the executors until unless you tell them let's do the store this data because I'm needing it further. Let's suppose, let's just consider this scenario that I am just using it only once. I don't going to use further in my other transformation. Then there is no need to store it, right? Why would I store it?
Yes.
Because storing will also be expensive, right? You are storing it somewhere, this is that will take the memory and all. Why, if I have to do only one time, then I won't, maybe I am not storing it. Maybe if I have to do two time also, if I'm not going to use it, see, it all depends that what is the data set. If I'm going to use it two time, I may do it, I may not do it. Because if I'm using the memory to store it, then ultimately it is also taking my space.
Got
So
it.
so if you want to store any intermediate RDD, then we use the persist. Okay.
Persist is like a variable.
Yeah, it is variable. Once you apply on RDD, like let's suppose I got one RDD after filtering. Let's suppose I have RDD one and I use some transformation. I got RDD two, and then I did some transformation. I got RDD three. Okay, and I want to save this RDD three. Then I will do RDD three dot persist.
Okay.
Okay, and then it will save it. And then after that, I want to do something on RDD3, I can directly use it. RDD3, I will do some transformation, I will get RDD4. It will store it somewhere into the memory. And let's suppose that I need it some other places. Then I will just directly read that RDD and I can use it.
Okay.
So when you persist RDD, the first time it is computed in an action, it will be kept into the memory.
Okay.
So there are different storage level. So as I told you that I am storing, right? So either I can store into the memory, I can store onto the disk. Disk space means hard disk. Okay, we on our computer we call it a hard disk. So in the servers also we have memory as well as disk. So different storage level is like there are two way. One is RDD.cache, one is RDD.persist. Okay, so when you what is difference between this is also one interview question. What is difference between RDD persist and RDD cache? So in the RDD cache, it only use memory. If you do the RDD cache, it will only store into the memory. You can think it's like RDD.persist memory only. Okay.
Okay.
But in RDD persist, you have different storage level. In RDD cache, we have only one storage level, which is memory. And so these are the storage level. So you can either do the persist in memory, you can do persist memory and disk. When you do memory and disk, okay, why when we are doing this memory and disk, let's suppose that I have uh, after RDD, which I want to store, it has 20 GB of data. Okay, but my memory has only 18 GB of data. Let's consider that. So what it will do, it will so storage capacity, I only have 18 GB of data. Okay, so what it will do, it will store 18 GB into the memory and 2 GB onto the disk. So whatever the data spill over happen, like let's suppose I have only 18 GB capacity, I need 2 GB more. So that 2 GB will be stored onto the disk.
Okay.
If an RDD does not fit into the memory, then partition does not fit, store the partition that does not fit on disk and read them from them when they are needed.
As once again, like storage level means something. It stores whole 20 GB data. 80.
Yeah.
Yep.
Wait,
And
wait. Go ahead.
storage level is something it stores whole 20 GB data, and if only 18 GB is used, then 2 GB is stored in the memory.
No, no. Memory is a storage level. I have on your server, let's suppose this is your worker node, right? On the worker node, you have memory as well as disk space. Like in your computer is also a server. You have RAM, like 8 GB or 4 GB RAM you have, right? That we call as memory. And hard disk is your disk space where you're storing, keeping your file. So once you, let's suppose you are trying to, when you gave memory persist as memory, sorry, storage level as memory only, so it will store all the things into the memory. And see here what it mentioned, if RDD does not fit into the memory, let's suppose I have 20 GB of data and I gave memory only, and then what it will do, if it does not fit the data, then some partition will be cached and will be recomputed on fly each time. Let's suppose that I have from the 20 GB, I can store only 18 GB, and 2 GB data will be again recomputed once you
It
try
will
to
store
read it.
it. Okay.
Okay, but if I'm giving memory and disk, so what it will do, it will store 18 GB. Let's suppose I have only memory left is 18 GB for the storage. Okay, and I want to store the 20 GB data. If I give the memory only, then it will store the 18 GB from the 20 GB data. It will store the 18 GB data, and 2 GB data it will again calculate whenever I try to read it. It will again
Okay.
calculate from the RDD. If I give the memory and disk, it will store the 18 GB data onto the memory. Okay, and as the memory is full, then it will store 2 GB data on disk. Got
Okay.
it? And memory only serialization is, it will serialize the data object byte by byte, and then it will store it. It is actually a space efficient, so that's why we are doing it. But in this, if you do the serialization, okay, then while reading you have to do the deserialization, so it may take at some time. Okay, because you are doing the serialization of data, and then you just read about the serialization and deserialization of the data. Okay,
Okay.
we do it by to sending over the network, we do it, just read about it, serialization and deserialization of data. Here one more option is memory and disk serialization, same thing, it will use the memory and disk, but it will serialize the data. Okay, now next is disk only. So when you give disk only, it will only store onto the disk. So these are the five partition level, sorry, five storage level, not the partition level but the storage level. Like memory only, memory and disk, memory only serialization, memory and disk serialization, and disk only. So basically you have only two places where you can store memory and disk. Okay, so when you combine these two, first like only memory, only disk, memory plus disk is third, memory serialization fourth, memory plus disk serialization fifth. So these are the 5 way of storing storage level. Okay. Now, tell me one thing. If I have uh, 20 GB of storage, right? And let's suppose that I want to store one a.txt. Okay, I got some final result and I want to save it. So on the 20 GB, I save it, right? And then again I want to save another file b.txt, which is of, let's suppose also it is of 20 GB. Then if I want to save, what will happen? What will happen to a.txt? Actually, it will remove the a.txt and will store the b.txt. Okay. If you don't have memory and if you try to store something new, it will remove the old one. Now let us take one more example. We have this server. You have one server and you are storing the data in it. Okay, multiple data you are storing in it, and a time comes when your all the disk is full. Okay, now you don't or you or your memory is full. Now you don't have any space left, and now again you try to store the data. So let's suppose if you have multiple files you're storing the memory, okay, and you want to store some new file, and here there is no space into the memory. So what it will do, it will remove the last used file from the storage. So we call it least recently used. Okay, so
Least recently used. Okay.
yeah, least recently used. Whatever the file which have you, let's suppose you have a file, b file, c file, d file, and you are maybe once you store it, you will keep using, right? Maybe you are using b somewhere, c somewhere. So whatever the file you have, let's suppose, and now there is no space, then will remove the least recently used file. So whatever the last file which have not used from last time, it will delete it. From longer, let's suppose the most longest file which is kept idle into the memory, that it will remove. Okay, these are some things you can read it once I read to share the slide with you. So whenever you are submitting any job to Spark, we have already covered this. I'm just going through it again. So
Okay.
whenever you are submitting the Spark to the driver, what will happen? Driver has the Spark context and a Spark session, and this will be your entry point into it. Okay, and you will create a plan out of it. I told you, right? Yesterday we saw about the logical plan and the cost-based plan, right? Where you have unresolved plan. Then from that you were creating the logical plan and all. So it will create the plan, and then you have the drag scheduler, and then you have task scheduler and cluster manager. We are going to look at that, what DAX scheduler is doing, and how it is optimizing the things, and how it is creating the task and all. Yesterday I told you, right? For one partition you will create one task, right?
Yes.
Now let's just look at what tag is doing.
Okay.
So whenever you are doing anything, let's suppose these are the some of the steps which you are doing on the RDD. You have one line which you read it, you did the flat map, you split the line. Okay, then you are actually this is program is to count the number of word. Okay, so these are the steps we are doing. Let's suppose just look at it like you are using flat map and reduce by key.
Okay.
We are calling the RDD lineage. RDD lineage, I told you, right? RDD is resilient. Means if something happen, if something fail in between, it will automatically recover. Let's suppose that RDD was doing these steps. These steps it was doing, and after when it was doing this step, it failed. Okay, and let's suppose that you have 1 GB of data, then it will create 4 partitions out of it, and these partitions P1, P2, P3 and P4. Okay. So let's suppose these partitions were running on multiple worker node. P1 was working here, P2 was working here, P3 was working here, and P4 was working here. So let's suppose all the partitions will perform these things. And on the P4 while doing, it lost the it something happened, and network delay happened, and it lost it. Okay, it lost the job. So again, when Spark has to calculate compute, you don't have to start again these things. You have to just recompute only P4, because Spark has this RDD lineage. It knows that what it has to do, and it knows that only P4 partitions have failed. Okay, it knows that only P4 partition has failed. Then why would I start these jobs again? Then what it will do, maybe on the another worker node, it will start the P4 and it will do this RDD lineage because it know that I have to only do these things. These steps I have to follow on the all the partitions. So this we call as the RDD lineage. Now what is DAG? DAG is like before that, let me just tell you about the narrow and wide party transformation. Okay, what is narrow transformation and what is wide transformation? Let's suppose that I have a file where I have A, B, C, D, okay, and I want to make it lowercase. I want the output into A, B, C, D. And let's suppose that I have two worker node where these things are working. Okay, A, B on this one and the C, D was working on this one. Okay, so on this worker node, I was processing AB, and on this worker node, I am processing CD. So now you tell me, do I need to transfer the data from any in between these executor between these worker node or not? Or let's suppose I have driver here. These are connected. Let's suppose these are not connected. Yeah, tell me now.
AB is one transformation, CD is one transformation.
Yeah, this AB was working. This data was on one one worker, and this data was on another worker because we divide our data, right? Let's suppose I have this file is of 256 and
Yes.
256 MB. So I will divide it into 128 MB, two file, and then I'm running on the two different workers. So can you tell me, do I need to shuffle the data here or not? Because I'm just transforming it from capital to lower.
Not required.
Not required, right? And
Yes.
now let's suppose that I have that employee table, right? There I want to group it by age.
Then we need to, it depends on the transformation.
If I want to group it by age, let's suppose I have worker node here and I have worker node here. I have
Yes.
data like one ID 1 age 30, or here also ID 2 age 30, okay, and ID 3 age 30, ID 4 age 20, something like this, okay. So let's suppose I want output is like 30, then all the IDs 1 2 3, and then for uh, age 20, all the age with their ID I want. So I will get output with like this, right? Because
Yes.
as the age 1 to, so in this, do I need the data shuffle, data movement from this to this and this to this,
Yes.
right? So wherever I need to do the data shuffling from between the worker node and between the partitions, that transformations we call as the wide transformation. And where you don't have to do any data transfer between the partitions, we call it the narrow transformation.
Okay.
Okay. So if you are applying any transformation where you have to do the data transfer between the partition, we call is the wide transformation. Else we call is the narrow transformation. So actually, DAG, okay, it will DAG will help you to run the job. Okay, so for your full this one program, it will create one DAG out of it. We'll see. I will show you on the Spark cluster how it is creating the DAG. So you just understand here, DAG will create a stage on the basis of the narrow or wide transformation. If you have narrow transformation where you don't need the data movement, then it will create one stage for all those narrow transformation. Okay, and if wherever you have wide transformation, then for each wide transformation, it will create one separate stage. Stages means uh,
Set of actions.
right, set of actions you can tell. So it will create one stage set of not action but the transformation. So it will create one stage where for all the narrow transformations and one stage for the for each white transformation, it will create one separate stage.
Okay.
Okay. So it is not like that. See, let's suppose that after reduce by key, I am also doing map on it. So I cannot segregate this map and this map, right? You are getting.
Yes. Yes. Yes.
Then let's suppose I have again map on top of it. Then it will create one more stage, like stage 3, where it will do map. Because see here I could have treating the text file flat map and map. Flat map and map is working on each element, right? I told you, right? So as it is working on each element, so I don't have to do the data transfer. So that's why it has converted it into the one stage. But here reduce by key means data shuffle will happen. That's why it is created one more separate stage.
Okay.
Okay. So these are the stages. Actually, RDD lineage will create something like this. Then DAG will create the stages, and your stages will have the task and all. You
Okay.
will see on the Spark that stage 1, stage 2, stage 3 on the Spark UI, you will see that. So this is actually the stages are created by the DAG. I think I have given a lot of information in these slides because this is one very important thing which people should know. Okay, I have loaded it with lots of information. Okay, see this wide and narrow transformation.
Okay.
Each partition, each partition's output depends on the one partition of the input, and each partition depends on the multiple input partitions, right? Because here the data shuffling is happening.
So this is different slide than the one you. Okay, it's not added in.
Sorry,
I mean, yesterday you have sent a
no,
slides,
no,
right?
I have not sent you this.
Okay.
The fault recovery via lineage in the RDD. See, this is RDD has flatMap, and the reduce by key. And let's suppose something happened to this reduce by key, right? So then it won't start this. It can recalculate it from the map. If these stages, generally these stages are happening only one executors. Okay, so let's suppose this failure occurred. So Spark know that on which partitions I was running this. So it will go to that another executor, take that partition on which it was doing, and then it will recalculate it. So that's what the fault recovery in the lineage. See here in the DAG in the Spark is like you have text file, then flat map, then reduce by key, group by, and these are the steps happening, right? So for the uh, when you have text file, right? This is stage 0 because you are just reading and doing the flat map. Here it is the narrow transformations. Then again, here you have wide dependency, right? Reduce by key, group by key. These are the wide dependency. So that's why we call as the it has created the another stage. Then again you have map and save as text file. This has the narrow transformation. So that's why it has created the again another stage. So for each narrow transformation, it will create one, and for each see it will combine the multiple narrow dependency, and for the each wide, it will create one stage.
Okay.
Okay, so I think these are the only thing in it. Okay. These are I have added so to read it for you, just read it. What the task scheduler and DAX scheduler is, those things, all things mentioned here. You can read it. See, you have a Spark job in that you have the DAX scheduler and the task scheduler. So what task scheduler will do once the task scheduler break the job into stages, the task scheduler take each stage and break it into the task, one per partition. Okay. So stages will created by the DAG, and then task scheduler which convert each stage into the task. So these are the component here in the Spark. So you need to know what the responsibility of these things. This may be the interview questions. Okay, so what is the task scheduler will do, what the task scheduler is doing. Now, task scheduler will schedule this job onto the executors. It will check with the yarn like where I should run. So let's suppose Jan tell him that okay, give the resources that run on the worker node 2. So this task will be scheduled on the worker node 2. I think yeah, that's it from here. From tomorrow, we will start Scala. Okay, because Spark we have covered almost, not I would say from Spark. If I leave Spark streaming, then I think from Spark we have covered 80% of the thing. 20% things are still pending. We'll see that. And then Spark streaming is pending. I will share with you this slide and just go through it and come up with your questions. You have 2-3 days time. And once I teach you Scala, I would suggest go through it, keep practicing it because you need it for the Scala Spark programming also.
Sure. Okay.
Okay, thanks, Reshma. I will share this slide with you.
Thank you, Rai.